Hi everyone, my name is Faizan. I'm the co-founder of Headstarter, and this is going to be an overview of the fourth AI project in the Headstarter Accelerator program. For this project, we're going to be building a self-improving agent that predicts stock prices. We're going to be constructing a neural network based on all the hyperparameters we select here, and then use it to predict the prices of any stock we specify. For this demo, I'm going to be using Apple stock. With all these hyperparameters selected, I'm going to start training the model. And as the model is training, we can also visualize the loss function in real time to see if the model is actually learning, and then we can view the results of the training run right after. So this is a live view of the model being trained, and we can see the loss function here. And so the model just finished training. We can see the mean squared error is 17.4. That's not too great, and you can look at the predicted prices for Apple stock here compared to the actual Apple stock prices. And so you can tell from this graph that the model wasn't able to accurately predict the stock prices of Apple at all, and that there's a lot of room for improvement. So because this model's predictions are not that great from this initial training run, what we can do is retrain the model with different hyperparameters. Now, choosing hyperparameters can get quite tricky because there are a lot of different possibilities and variables that can be changed. So instead of spending time thinking of what hyperparameters to choose in the next training run, we can feed all the information about the model architecture and training history to an LLM and make it determine which hyperparameters to use for the next training run. So this is the result of this initial training run here. And then we can view the results from the next training run here. So this is iteration 2, it's currently being trained. So at the end of each training run, what we do is we take the model architecture as well as the training history and the loss function at each epoch, and then we feed that as context to an LLM. And we tell the LLM to basically suggest improvements to the model architecture so that the accuracy can be improved. So this is the model suggestions, what it's saying here. Then we use another LLM to extract the structured output from the suggestions provided here so that we can retrain the model using these new parameters here. So with this architecture, it's 128 recurrent neural network neurons in the first layer, then 64, then 32, then 2 dense layers with 64 and 32 dense neurons as well. So from there, we can see how the parameters change in each iteration. So in this one, we go from 32 to 16 to 8 to 4 to 2 recurrent neurons in each layer, and then it goes from 16 to 8 to 4 dense neurons. And so for each iteration, it goes through this pipeline. It takes into account the history of each iteration, and then it uses that as context to provide parameters for the next iteration of training. So you can see how in each iteration, the model's parameters are different. So after 5 iterations of going through the self-improvement pipeline, we've gotten to this accuracy, and this is how the model's predictions compare to the actual stock price of Apple. So there's still a bit of a delay and lag between what the model is predicting and the actual stock price of Apple. And I just want to give a disclaimer here that you should not use this to make investments without doing your own research. This project is only for research and educational purposes only. So with that being said, we can see that maybe with some further tuning and refinement that we can get maybe more accurate predictions from the model. And we can see here that compared to the actual price, the model is a bit off in what it's predicting. So from the initial training run, we can see how the model's architecture changed and how its accuracy improved through the self-improvement pipeline that we set up. So in this first iteration, we have 2 recurrent neural network layers, each with 64 neurons each, then 2 dense layers as well. And in the final iteration, we end off with 3 recurrent neural network layers, starting with 128 neurons, then 64, then 32, and then ending off with just 1 dense layer with 16 neurons. So this is done through the self-improvement pipeline that we've set up. What happens is that the architecture of the model and the accuracy will likely converge into a number, and that will serve as the highest possible accuracy with the dataset given and the model architecture. So overall, this project will teach you a lot about the fundamentals of neural networks, since we will be writing the code to build them layer by layer based on the selected hyperparameters, and also visualize the model architecture as shown in the beginning here. So you'll get to learn about the differences between LSTM neural networks, which stands for long short-term memory, and GRU neural networks, which stands for gated recurrent units. Both of these architectures are used for processing time series data and making predictions with them. Then you learn how to feed all the model's information and training history into an LLM to generate structured output containing a set of hyperparameters to use in the next training run. So we'll then put all that together and create an iterative process that serves as our self-improvement pipeline. So this is an overview of the fourth AI project in the Headstarter Accelerator program, and I hope you all are excited to build it with me.